Hi, this is Christian again with week 2 screencast assignment. We were given the problem that a robber is trying to escape from a bank that he just robbed, obviously. And the bank is a 5-story building, which is roughly 50 feet, or otherwise 15.24 meters. And we were asked that what is the possible distance between the bank and the building next to it, which is a 40-foot building, or 12.192 meters. What is the maximum distance that those two buildings could be away from each other, and that the robber would still be able to jump from the 50-foot building onto the 40-foot building? So, how I started was by listing all our knowns and unknowns and drawing a picture. You're not going to be able to see the text, but it's all on here, all the math. So all our knowns were that the height of the bank was 50 feet, or 15.24 meters, and that the height of the second building next to it was 12.192 meters, so there's a difference of 3.048 meters. We were given that the robber jumped up at a velocity of 10.4 meters per second with an angle of 10 degrees. We know that the acceleration in the x direction is 0, and the acceleration in the y direction is the force due to gravity, so 9.8 meters per second squared. We were then asked to find the maximum distance between the two buildings and the final velocity that the robber would land at. So I first started by calculating the individual components of the velocity we were given. I calculated the x component and the y component, and that you could do by a little trigonometry. So you know that your hypotenuse is the 10.5 meters per second, and it was at a 10-degree angle. So with doing the sine and the cosine, I calculated that the velocity in the x direction was 10.3 meters per second, and the velocity in the y direction was 1.82 meters per second. Having calculated that, I then went on to solving for the maximum distance between the two buildings, and I did that using the formula x equals initial velocity in the x direction times the square root of twice the height divided by gravity. And so that gives us 10.3 meters times the square root of 3.048 meters times 2 divided by 9.8 meters per second squared. And that gives us 8.12 meters. So the distance, the maximum distance between the bank where the robber is first standing on and the building next to it is 8.12 meters. So that's one of the things we were asked to find. So I found that. Next, I had to calculate the final velocity in which the robber lands at. But first, I need to find out time, and I did that by using the formula x equals x initial plus the initial velocity times time. And then you could rearrange the formula and solve for time. So then your new formula would be times equals the distance minus the x initial, which is where the robber was first standing at, and in this case could be 0, all divided by the initial velocity in the x direction. So 8.12 meters, which is the distance between the two buildings, divided by 10.3 meters per second, which is the initial velocity in the x direction. And the exit gives us, 0.78 seconds. So having the time, now I could go back and calculate the final velocity that the robber lands at. And that I calculated by, onto the next page. So we know that the velocity in the x direction should be the same. The final velocity in the x direction should be the same as the initial velocity in the x direction. So that doesn't change, so it should be 10.3 meters per second throughout the x direction. But the velocity in the y direction should change due to gravity because there's the force being acted on it, so the rubber's being pulled down towards the earth. And I calculated that with the formula Vy equals V initial minus gravity times time. So then you do, God, I wish you could see my math, but no, the light's gonna be too bright. So that's 1.82 meters per second minus gravity 9.8 meters per second squared times time, 0.78 seconds. So then you have 1.8 meters per second plus 7.64 meters per second. So your total is 9.46 meters per second. And that is your final velocity in the y direction. So now you have your final velocity in the y direction and your final velocity in the x direction, but you're being asked to find the final velocity altogether, so it has to be a vector quantity. And then you can find the final vector quantity simply by doing the Pythagorean theorem. You know that x squared plus y squared will give you your hypotenuse squared. So then 10.3 meters per second squared, which is your velocity in the x direction, plus 9.46 meters per second squared, which is your velocity in the y direction. That equals 195.58 meters per second. And then you take the square root of that, and that gives you 13.98 meters per second. And that should be the final vector of the x and y. That should be the resultant vector. So that is your final velocity that the rover lands at, and that would be so the magnitude of that is 13.98 meters per second, and the direction is north south, because he's jumping from a 50-foot building onto a 4-foot building, so the vector is in this direction. Okay, so there was a lot of math to it, and I know it could get a little complicated, but in the end, what we were asked to find was the maximum distance between building A and building B, and that was 8.12 meters. And then we were asked to find the final velocity that the robber lands at building B, and that is 13.98 meters per second. So that's that. I'll see you next week.